Hello, everyone.
Yes, we're doing this because when we're turning on our cameras, I feel the class is so warm. Okay, yeah. So, um, data collection and data analysis in scientific method. Um, Next slide, please. Yes. So tonight, the project is not going to be just a bunch of slides we're going to present. Actually, we consider the topic ourselves by the group IF, which is analyzing the data and data collection on effect of salt on boiling point of water. And this is a chemistry class at this wonderful school. Yes. Group IF, meet our brilliant team. Myself, Shohra Azami. Team leader, Sakina Rizoda, Wahida Behishti, Wido Jone Rizoda, Shahlo Amin, Shukriya Jone Alizoda, Wasahar Jone Darwish are our wonderful team members. In this project, we're going to answer the following questions. What is data? How is it collected? How is data organized? How data is analyzed? And how conclusions are actually drawn. These are the 5 key concepts of the project. Next slide. Yeah, a very common question. What is data? This is the best part in the class to understand what data is in the scientific method. Because most of the time we're talking about data collection or data analysis, while we don't know the meaning of the word data itself. So we have to dive deeper into the word data first to move on to the next parts. Data is the information scientists collect during the experiment to answer the question that was asked in the hypothesis stage. Data has types. The most common types of data in scientific method are quantitative data and qualitative data. But remember that I'm not going to dive deeper into them because in the group A, I noticed that they were doing it. So now understanding about quantitative data, what it is. Quantitative data is the data that can be measured or counted using numbers. It can be written in as a number because the hint is in the name itself. When we talk about something, we have to be understanding it by mind, not just words. So when we say the word quantitative, what is the word quantitative itself? It's coming from the word quantity. So the word quantity is definitely referring to numbers. What numbers? Like temperatures, time, volume, boiling point of water, or salty water, and so on. For example, temperature, 25 degrees Celsius. So that 25 degrees Celsius is actually referring to numbers, 25. It's the hint is in the words, numbers themselves. So we have to be understanding the word quantitative, which is 25 degrees Celsius. Or in physics, biology, chemistry, we have, for example, a car is moving a distance of 6 kilometers in 20 minutes. So that 20 minutes is actually the word that is coming in the part of the quantitative data. And the same is here, like time, 1 hour or 60 minutes, or usually it's represented in seconds in metric or SI system. Volume of water, which is 500 milliliters, and boiling point of salty water, which is 105, between 105 and 108 degrees Celsius. And then in the next part, we have the qualitative data. Again, the hint is in the word itself, qualitative. It's referring to sentences, not numbers. Qualitative data is the data that is descriptive data, and it's describing qualities or characteristics of something. A project we're doing, a scientific method, something that we're experiencing, testing, experimenting it. So it's referring to the sentences. For example, color of the light, it could be yellow, it could be blue, it could be red, or it could be white, like the light that we have on Earth. and then the rest of the yellow, blue, red, and so on are out there in the universe of stars. And then reaction of speed, like slow, fast, medium. Is the water slowing, boiling faster? Is it boiling slower? That's the qualitative data that we can actually move on. And then in the part of the chemical compounds, we have smells. Smells of gases of hydrogen, helium, nitrogen, oxygen, and so on gases. We have them. So the smell could be actually strong, weak. That is referring to qualitative data. And then in the next slide, we have about,
Well, it's my
yeah,
turn, Shohra,
yeah,
yeah. So
yeah,
as
you can
my
move on.
yeah, as Shorajan explained about data and its main types, so we're gonna know that how we capture these data and how we collect them. So either in science, in physics, or in chemistry or biology, we have three specific and organized ways for collecting data. They are number one, measurements, number two, observation, and the most interesting one is surveys and tables. So we're gonna sorry, measurements right now. So measurements is not about gathering numbers. It's about gathering precise and repeatable numerical data. So we can use tools like rulers, we can use like measurement tapes for length or distance, we can use thermometer for temperature, and we can use stopwatches or timers for getting and recording the time of that chemical experiment. So without measurement, an experiment is nothing or is incomplete because it's like a part of our bodies. And then we have observation, as our previous friends also explained this one. So observation is the exact way or carefully way of noticing and recording the data. So it can be both collective, sorry, that was it can we can collect numbers, and also we can record what we see, what we hear, or even what we smell. So but the question here is that how we can even better observe. We can use tools like microscopes, like thermometers, like cylinders and stopwatches for better observing this one. And then we have experimented boiling water in salty water and also plain or pure water. So in boiling water, as we observed, the plain water bubbles vigorously and very rapidly, while salty water bubbles less forcefully and less slowly. And for quantitative observation, we observed that the boiling water start boiling at 100 degrees Celsius in 5 minutes, while the salty water takes like 7 to 8 minutes and boils for 103 or 105 up to 108 degrees Celsius. And the other one that we are going to know is about surveys and tables that we can organize them in a correct way, and very organized information. We can record them by using them, as my other classmates also explained this part. So our table is we have types of water and the amount of salt, boiling point, and also the minute that they boiled. So in pure or plain water, the amount of salt was zero, and it held the boiling spot at 100 Celsius degree and in 5 minutes. But for salty water, we had 15 grams of salt in that, and it hit it at 103 Celsius degrees and in 8 minutes. That equals to 480 seconds. Turn.
Okay. So don't want to take your time more. The project is going to be too long because we did a lot of research on this project. Organizing data, and then it's the most important. This part, we're actually concluding the charts, the graphs, the tables that we did on the project of boiling water. Is the salty water boiling faster, or is the mineral water? So organizing data means putting the data putting the data you collected into a clear, logical way. That the main point is what type of form? This is the question. Okay, I'm not just going to read the slides. When we talk about putting into a specific form, what form are we talking about? So the forms, we can actually put the collected data in our tables, which are super structured, charts and graphs, which it is visual because we could actually see and understand them visually. And units and labels like meters, seconds, degrees, and so on. Okay, graphs and charts, which graphs we could actually see them. It's like as if I'm touching something. And then it's linear graphs, it's bar graph, pie graph, that we have different types of them. And then the most important part are the axes. Okay, we have axis, which is one, and axes, which refers to a bunch of axes. So we have x-axis, which is usually the horizontal line, and then the vertical one is going to be y-axis. It's going to be the x-axis is going to be the temperature, not all the time, okay? It's not going to be all the time. The project that we did, temperature is included in the vertical line, which is y-axis. In the x-axis, okay, in the x-axis, it's going to be the seconds or the time. So this graph would show that as temperature increases, then the number of the minutes are also increasing. This is the graph. It's so perfect. I really like it because it's based on the data we collected. So you see that the boiling comparison, pure water versus salty water, can actually be that as the number of the minutes increase, also the temperature is going to be increasing. Next slide. This is just one type of graph that we have. Then the next part of the type of the graph that we're going to have is going to be, yeah, I think Sakina John's, yeah. And then this is the second form actually. Okay, it's like we have a bunch of girls, or all girls are not going to be the same. And this time, Sakina John is going to be like a different form. So that is exactly how data is going to work. We have different types of forms of charts. That was the previous chart. This is the second chart, and this one is the third one. Those blue red points you are seeing are actually referring to the data, the temperature, and then the minutes. We have also electricity. Next slide. And then in the part of analysis, it's very important in data collection because it refers to the comparing the values, the temperatures, the boiling points, the minutes, looking for patterns, quantifying the change of the increase. For example, the difference between 100 degrees Celsius and 102 is actually two numbers or 2 degrees. And then that is the quantitative analysis. In connecting it back to the hypothesis, we could say that the hypothesis is actually adding salt. We could say that adding salt increased boiling point, and data result could actually be boiling point increased, and the data supported the hypothesis. Drawing conclusions. Drawing conclusion is the step where scientists use their analyzed data to answer the research question and decide whether the hypothesis was correct or not. For example, my team and I did a research on salty water and mineral water. So I and my team created a hypothesis. And the hypothesis was that if I would be putting a lot of salt on a teapot, it would be putting it on a stove, and I would be observing which one is boiling faster. So I saw that the mineral water boiled at 100 degrees Celsius, but the salty water was boiling at 102, 103, and if the amount of salt was too much, then 105 degrees Celsius. So the data that I collected, is it supporting my hypothesis? That is exactly the drawing conclusions that we refer to. We have to be understanding it by mind and logic. Drawing a conclusion means explaining what the results mean based on only the data, not my imagination, not my thoughts, not my opinions, based on the data I collected. And in conclusion, we could say that we asked the following questions: how does adding salt to water affect its boiling point? And then we refer to the hypothesis that if salt is added to water, then the boiling point will increase above 100 degrees Celsius, and the experiment and the data collection that we did was completely correct. So now, if you have any questions, uh, our team is ready to answer them.